Welcome everybody. Today is second part is about strings. This is D17 part 2, a revision or a retake of the D17 that I already submitted. Okay, I found that the quality of the video was not that good, so I'm resubmitting it as part 1 and part 2. So I divided it also the D17 into 2 parts because it was becoming too big. Okay. So in the first part, I talked about Ascii characters. I explained Ascii characters, and I will quickly review that here again. So Ascii refers to the that's where your keyboard is mapped to the system response. Okay, in terms of whether representing a particular character, number, or special characters, or special functions that you need for the system to respond to. Okay, so for example, it's a 7-bit character set containing 128 characters. It contains the numbers 0 to 9, the upper and lower case of English letters from A to Z, and some special characters. Okay, the character sets are used in modern computers, in HTML, as well as on the internet, are all based on this ASCII system, which is American Standard Code for Information Interchange. So here is that table again. If you want to see that number 10 in the ASCII list of collection of items, if you locate the 0, it refers to null value. If you look at 1, it starts start of heading. So this is not something that you can print it, right? So these are all non-printable characters. Up to this backspace, horizontal line fit, all these things are non-printable, isn't it? Vertical tab, line fit, shift out, shift in, all those things. Okay, so it starts our regular English character. These special characters are all okay, like exclamation, space, exclamation. This double quote. It's a double quote, and then the hash, dollar, percentage. All those things are okay. The actual thing, number starts with number 48. In the ASCII collection. Okay, number 48 refers to 0 and then goes on up to 90 is uppercase Z. Okay, and then 91 to 94, some special characters, and then 95 is 95 is underscore, and this is the left quote, special left quote. 96. The decimal refers to the decimal number, and the hex refers to hexadecimal number referencing, and the actual characters are here. So we talked about that. Now let's just I'm going to print again pip3 install ASCII. We did that. We have shown all those things. So let's move on. Move on to the strings part of it. Okay. So from string, I import everything because there are a lot of things like lowercase, uppercase, ASCII letters, printable, and so on. So we get that here. The printable is coming from ASCII. I'm sorry. The printable is coming from ASCII, and then the ASCII package, right? That I already talked to you. So here it is, printable. From here, ASCII, import ASCII, and then printable is coming from there. There is also printable available from string. Okay, so let's take this one. I covered that before. So let's talk about only string functions from now on. Okay, even that is there is 35 plus string functions that I'm quickly referring them. So just hang in there another 10 minutes. Now I'll finish that one. Okay, so from string import star, and for C in ASCII lowercase, there is something called ASCII lowercase here available. For C in ASCII underscore lowercase, print each of the characters, but when you print them, you end it with a comma and space, and then you go to the next character, you end it with a comma and space. That's how I am able to separate each of these printable lowercase letters with a comma and space. Okay, and I can do the same thing for uppercase. For C in ASCII underscore uppercase, that's coming from the string. Print C comma end is equal to within quotes comma space. I do the same thing. I do the same thing for ASCII letters. This time, this means it puts together ASCII lowercase and ASCII uppercase. That's what these ASCII letters are. Okay, and then I can also print everything now as before. Print S. It gives you all these things. Okay, there are some non-printable characters here. So in the this one is, remember, this s is coming from let me just be very careful about this. S is coming from string. Okay, that's fine. String printable. Okay. All right. So that's why this reference number may be different. That's why that's where I am going. Okay. This is 6. This is 100. So this is 93. 94 is starting. 93 is your tilde function, right? This tilde may not be in ASCII reference list, right? Remember, because ASCII refers to 128. This is only talking about 100, starting with 0. Okay. Be careful about it. So I don't want to go back to this one. We already saw all those things. Okay. So let's just go to this special interesting string I'm going to use as a case study. Okay. So this string is understanding how strings are manipulated is the foundations of or the foundations of NLP. Okay, is the foundations. Understanding, so it is okay, is the foundations of NLP. So that string I'm going to manipulate it for various things. I'm just first going to check length of that one. It turns out to be 68, and I use the function called length. But this is not the this is a Python function, okay, not string specific function. So when you have a string specific function, you will apply the string dot, and then you will start applying. Okay. So for example, I want to split all the words from S. This S is different from the previous S. Remember that this S is referring to this particular string, and I want to split all these things into words. So you just say S dot splits with a space within the quotes, then it will split all of them into words, and that turned out to be these words. Okay, so these are the words. Understanding how strings are manipulated is the foundations of NLP with an exclamation. That is, together is a word. Now, how to find specifically an indexed word? So you split that collection, and then if you say 0, it's now you are using the slicing function from list, because this is a list. Okay. Understanding is the first one. -1 refers to the last word, that is NLP, and the fourth word from right refers to manipulated. And if I want to convert everything, the whole structure, understanding how strings are manipulated is the foundation of NLP. If I want to convert them into whole structure, into upper, you just say S dot upper within parentheses. So everything got converted. I can also convert it into lower. There is no uppercase at all here. No uppercase at all. By the way, the S is not. It is not changing anything to the S. S is still the original one. I'm just applying it, and it gives me the output. Okay. Whenever it comes out to be output, it is not changing it in the original object. Okay. If you want, you can store this into something, and then you can call that also. Okay. And you can capitalize. That means only the first letter in the whole sentence will be capitalized. But when I did that, see that one, that it changed the uppercase NLP. It changed it also. So if you don't want to affect this one, special names and so on, you have to do a lot of work. But realize that when you do the capitalize, it is telling only the first letter. There is also another function called title. I take the same string, and then now I'm going. This is not my the string I'm working with. Remember now. Okay. After I apply, it is just immediately spits back. It doesn't retain it. Change that into S. In place, it doesn't do the in place replacement of S. So when I do the S dot title, then it will make it as if it is a title function. Title expression. So every one of the words will have uppercase. Okay, that's what it is here. You see. Okay. Again, NLP got only the first letter N as the uppercase. L and P got lost. Now, if you want to fix it, again you have to do much work, and you will see one work. I will show it to you momentarily. Okay. And as I said before, I can always search, slice the outputs. After the split is applied, it is becoming a list of words. I can do the slicing functions into that one. Okay. And we already saw this one. -1 refers to because this is now all the way from beginning to the -1. So remove everything, keep everything, and removing the NLP. All right. So again, I'm recalling to tell you that S is still retained. Nothing changed to the S. Okay. This is a temporary value created by application of the dot function. Now I am going to do I did that second time. I don't know why I did that. I'm going to remove that one. So let's remove that. And then I I printed it again. Okay. Now if I want from fourth to all the other rest of the words, from the tail, start from the fourth, from the tail, and 4 words from the tail backwards, and then to the end. That's what this one, the foundations of NLP. Okay. Now let's just apply some of these things. I want to get a nice sentence like this. When I did that, it messed up everything, right? Remember, when I do this one, it comes out to be like this. I can't join these things. If I join these things, then the needs to be corrected with uppercase. And then when I join these things, should not be lost. So let's see how to do that. So I take this join is other function. So I know I got the S2 here. I saved this one. S2 is the collection of all these 4 words, and then I am going to join those. And I'm going to create a new string with the string. Create a new string with the space to start. Just that means it's a new string with space in between the words. Where I'm joining all the words coming from S2, take out the -1, that means take out this NLP, and then capitalize, that means the will get T, uppercase T, and then I'm concatenating. This is concatenation of words, okay, strings in Python, concatenating, but then I'm adding a space because I need a space here. So up to now, I have accomplished this. I took these words, and then out of that I took the first 3 words, and then I made the first letter of the first word as uppercase, and then I need to add a space here, and then I need to add from S2 the last word. But S2, the last word is it might just to make sure that all the uppercase all the letters in the NLP are uppercase. I also again apply it. I don't think you don't need to do that because it is still keeping this one as it is, so it should work. Let me check it out. Otherwise I can always add. Oh, S2 is not defined, so obviously I have to run this one first. Okay. S2 split words. What happened? S2 S split words, and then S2. S2 capitalize. Okay, so S2 is it's messed up. Okay, S is because S is not this word. I didn't run this S. Okay, that's the reason. Let me go back to this S. Okay, this is the original S. New S. Okay, now it should work everything. Anyway, I will run all these things, and then I will also know that I ran this. I am running this. It's all good. Upper, lower, capitalist, title, and then comes everything up to the last word of the S. Understanding how strings are manipulated is the foundations of, because NLP is not there. I'm printing again S, nothing changed in S though. I reiterated that. So these are the 4 words I'm taking, and I'm going to do this one. So obviously it has come out back. I don't need that uppercase for making uppercase for the last word. Okay, so that's good. Let's continue with this one. Okay. Again, I'm redoing this one. I don't need to let's redo. That's okay. S2 is there, right? I think I should keep it as not S2. S2 is only part of it. I see. That's the reason why I have to create this one split. Okay. So let's redo this one. I have everything except the last word. That's what this means. Split the original string S, which is understanding how strings are manipulated is the foundation of NLP. Split everything and then keep all the words up to the last word, not including the last words. That's what this is. That is what this one is. And then I want to append it to that. Okay, I can also do append because it's a list, right? I can append that. When I append, it becomes like this. So again, it's going to create some interesting twists. But let's say when I appended to the list S1 list, which did not have the NLP. Now I appended this one, so it becomes along with the NLP. Now I want to join these things, but when I put the prefix, the string, hyphen, the string hyphen, I want to join this string, join the string with this hyphen. Okay, that means all the words in S1 should be joined together with the hyphen. That's what this one is. Okay, so connector is hyphen. So again, I want to get back to see S1 and S1 looks list. Okay, good. I can also put just a space instead of hyphen. That's what this one is. String hyphen string space dot join all the words in S1. So when I do that, it becomes this one, right? Remember that one. This is what it is printed. Okay, that is the output coming from here, and then I am printing again S1. So that is this one. Okay, second part. There is also there is is upper, is lower. We can verify whether the whole thing is an upper, the whole thing is lower, the whole thing is alpha, the whole string is a numeric. It should be numeric. Okay, and then is the whole thing alpha num. We can check all those things. So let's go back to this S string, that is understanding how strings are manipulated is the foundation of NLP. I'm going to quickly check all this. Is this all upper? No, right? So this is going to come false. And then is it all lower? No. Oh, well, wait, what is going on? Is this upper? False. Is this all lower? What happened lower? Is this lower? Oh, because no. I applied lower, and then I'm checking, is that lower? Okay, applied lower. Of course, it will be true, right? I'm applying lower function, string dot lower. So that means it converts the whole string into lower, and then I'm checking with the is lower. Of course, it will be true. Is alpha? No, it is not alpha. Why it's not alpha? Because the special character is there, exclamation, right? Remember that. So it's not alpha. That's why it is false. This one, that's why it is false. Third one. Fourth one is numeric. It's not numeric because there is actually no number there. So it is false. Is alpha, is all num? Everything is numbers? No. That is all num. Okay. So that is also false. The last one is this, is all num. I'm checking, it says false. So let's just do this one more example. A124. That's a string I'm taking. I'm asking whether it is all num. Of course it is alpha and num. So true is alpha, false because there is number there. Okay. So it is false. And then I'm going to do some of these things here. Now count function I'm going to give you now. I take the S string here. So what is the S string here? Just checking it out. Let me just put it here. S string here. I need to print that S string, right? So why it didn't come? Let me put it here. Okay. So for some, because I have used multiple semicolon here. Okay. So if I do separately, it should work. So this is understanding how strings are manipulated is the foundations of NLP, and then I'm checking where is the in this one, all uppercase. That's what it's saying. No. Yeah, is there a da, and how many das are there with uppercase? Okay, that is it is. I think I will just do it this way, so that it will not work separately. So is there an uppercase there in X? Let me put it this way. 0. There is nothing there. Okay, so it is getting confused because of multiple commands. Okay, so I'm going to take this one. There must be 1 there, and this should be 0 there. Okay, this must be 1. No, there is no da. Oh, this is the one. There is no the. There is no other word called the with the T uppercase. Okay, so let's do this one and take out the lowercase. Now it should get 1. Okay, so there is one string. This complete string the in the S string. Okay, that's what it is, and it counts. Okay. Now I get back S here, and then I'm asking how many O's are there, and you can see 1, 2, 3, 4 O's are there. Okay, and if I am looking for space, 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces are there. That's what it means. So when I run this one, I get 9. Again, it is giving me a problem here. I have to run this command. Which command? You know what it is, right? In the beginning, I gave that to you, right? Let me go to that command and run it. This is the one. Okay, to get multiple print outputs in a cell. Okay, so let's run this one. Now I got 2 outputs, right? 2 outputs. The number of O in this string is 4. The number of spaces in the string is the same string is 9. So remember, when I do the find for a string, substring, it is going to give me the index of the first letter. Okay, so that's what this means. How do I know that it is correct? I put back that, and then I can get back the right. Let me see. Let's see what I'm doing. Okay, index. So I have to say index 45 to 45, 46, 47, right? 45 to 46. Let's see what happens. Huh? Well, no, let's just put index 45. Find, yeah, that's correct. Wait. So I did find starting position of the string. If not found, it will give me -1. It did find the starting position of the word the, and then it also found the starting position of the index, right? For the word the in the string s. Now, that is 45. So, so the index is, we know that the starts at position 45. So I want to go back to the string and find out what is 45. It should be t, isn't it? But then I want to find the 45 to 45, 46, 47. So I should put 48, right? Up to 48, because this is not going to be including this. It should give me the, okay? So I retrieved back. And if the word is not there, for example, the, T-H-E-E-E, it's not there, right? Whenever the word is not there, it will say the word is not there. If it is there, then it will find out the first position, right? There is no word, then it will say -1. That's what this one is about. And the R find is coming from looking for the first occurrence of the character that is given here, right? In this case T. Without R, it is first occurrence from left to right. On the other hand, if I put R, it is from that is let me go back this one. Find refers to searching for this character from left to right. And R find says finding the same character from right to left. So from the tail side of it, trying to move right to left and locate the position. So if you look at this one, it says the is from the remember, this is from the right, from the tail side. So that is a position 68. Okay, because there are multiple T's are there. That's the reason. Okay. The first T is 45. Remember, especially first T with respect to the word. Okay, because there is a first T here, which is happening 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6 position, right? That is the first T, and there are more T's are there. But the first T with the combination THE is S dot find within quotes THE. S dot R find within quotes T refers to you come back from the right, then this is the first T you find. It's only one character, so it will find this one first. So that turns out to be 68, and then that turns out to be 55. Okay, that turns out to be 55, and then I put back that 55. This is 55, right? I put back 55 into the S, then I should get back T, right? I did this just before. So those are the things. I want to also add this one, center, left just, right justified. So you take the string, and if you say I want the string to be placed within this 80 character position, but it should be in the middle, and then whatever is not the empty space, you fill it up with this one. Okay, that's what this means. On the other hand, the same string, you take 80 position space, and then put that string S string, but then left justify that. So the right side will be all this hyphen. Okay. On the other hand, if I put R justified, then I'm saying take 80 position space, put the string S, but then you right justify that. That means all these hyphen will be left of that string. That's what is happened here. You can see that it is centered here. Okay, here it is right, left justified. The string is left justified. Here the string is right justified. Okay. And also I want to bring you this very interesting F print. So you can print string with dynamically changing values for a variable. Print a string with dynamically changing values for variables that should be part of that string. Okay, so here is that usually this is a common work that you might do in printing. So here it's a I really want to print to deliver 1 hour of speech, one has to invest 100 hours of preparation, right? And I'm saying that prep h is 100, delivery h is hours 1. So I'm saying f within quotes, print f within quotes to deliver. This is the double parenthesis, what is called the squiggly parenthesis you have to use. Okay, and within that the parameter will be passed. The parameter value is already system knows it, so it will pass that one wherever you have the squiggly brackets. So delivery h, that means to deliver 100 hours of speech. I'm sorry, to deliver 1 hour of speech, right? Delivery h is 1. To deliver 1 hour of speech, one has to invest prep h, that is 100 hours of preparation. That's what this one is. It's a very useful, powerful print statement. I like it. And the other function, couple of more functions are, you can swap the case for the whole string or part of the string, but I'm just using swapping the case for the whole string, so it changed the cases from upper to lower, lower to upper. Okay, and you can also, again, if you put back 2 times, if you apply, it is reversed back, so it's basically you get back the original one. Understanding how strings are manipulated is the foundations of NLP. The last one I want to talk to you is about zfill. Interestingly, it is useful for zip codes. It's a very, in data science, it's a very interesting situation. Make sure that the zeros are not lost in the prefix type situation. This is actually where I lived in New Jersey. Monmouth County is 07726. But then when you manipulate with this one, you will lose the 0. So in order to make sure that you can handle that properly, there is something called zfill is available. So you take in number and then you put a zfill. It's always the prefix. Suffix is not an issue, right? Prefix is the one that needs to be handled, especially in the zip codes, right? So and if you have suffix zeros, it will work, right? So if something is 72670, it is not a problem handling. But if you have 07726, it will compress it to 7726. So to avoid that, there is something called zfill is available. So I'm saying I need to fill that zfill 5 with the number 7726. That means prefix, add whatever the number of physics you need to add, so that you will get a 5 number, totally 5 number, which is, in this case, I have to add only 1 0. Okay, so I give 5 position and give this string and do the zfill, means prefix as many zeros as possible. In this case, there will be only 1 0. So that's what it is here. Okay, I printed that. S4, I created that, and then type. I was just asking what the type. It is a string. Instead of 5 position, if I give 10 position, it is going to print 6 zeros here. That's what this has happened. I can also add plus and minus to it. So it will honor that. Along with the symbol, it will also add the zeros there. So that covers an extensive collection of string functions. And I also reviewed again the Ascii, importance of Ascii characters, how to work with them. Thank you very much, everybody. Have a wonderful time, and be curious and be studious. Okay, thank you. Bye bye.